Welcome to the Mu Analysis video on counterfeit detection in the electronics industry. Mu Analysis is an electronic materials laboratory. Mu Analysis employees are part of the SAE G19A Committee on Counterfeit Detection. Some of the counterfeit parts that we will show here have somehow managed to get into products and have been revealed during failure analysis. Others were discovered in counterfeit detection. Detecting counterfeit parts. Counterfeiting components is a multi-billion-dollar industry. Some estimate a significant percentage of parts are counterfeit. A counterfeit part is a part that is misrepresented. A counterfeit can be a genuine part, sometimes older, sometimes used. They are often cleaned, rebranded, and sold as new. Buyers believe that they receive genuine parts because they only deal with ISO certified manufacturers, but the parts are sneaking in on a massive scale. How could these possibly be sold as the same part? The counterfeit package was labeled as the same part. The suspect part on the left is in a 35mm package, while the part on the right is in a 27mm package. The counterfeit part does not even look the same. It has a completely different die. This example is from the early days of counterfeit parts. Since then, counterfeiters became more sophisticated. One of 5 capacitors taken at random from a reel. Many fake parts were found. This capacitor is laser marked, but strangely is handwritten. Here we have images of tantalum capacitors that failed in the field. They caused a failure in a critical medical instrument designed to keep the patient alive. We expect them to be identical inside, but during failure analysis, X-ray showed us that they were counterfeit. The real tantalum capacitor is on the right. On the left is the clone. X-ray reveals that this is a poorly executed clone. These are cross-sections of 2 MLCC capacitors. The cap on the right is a genuine flexotherm. The cap on the left was marketed as a flexotherm. We can see under a microscope that the one on the left is missing the flexotherm layer. Here we see a glass diode. On the right is a cross-section of the diode. Under the die, there is nothing attaching the die to the electrode. The top photos are X-ray images of 2 diodes. The bottom photos are SEM images of the corner of the diodes in cross-section. On the left is the original lead glass passivated diode. The right diode is missing the lead glass passivation that is shown on the left in violet. The yellow arrows show solder contamination identified by SEM energy dispersive X-ray spectroscopy, or EDX. The top arrow shows solder contamination, shorting the diode. The bottom arrow shows additional solder contamination. This part came to us for failure analysis, upon where we discovered that the root cause was a counterfeit part. This does not pass a visual inspection. Both reels have been oriented in the same direction. The counterfeit parts on the top reel show very weak markings and are mounted in the opposite direction. To rebrand a part, some counterfeiters will grind the package, which reduces the thickness. Scratches or clipped corners are telltale signs of rebranding. These are old examples. Counterfeit practices are improving. Blacktopping is now used to be less conspicuous. Parts are sanded and a new blacktop is applied. Then the part is rebranded, often to write a different date code. As counterfeiting practices improved, detection also evolved. Acoustic microscopy was used to detect ghost markings. 5 chips were taken at random from a 2500 part reel. Acoustic microscopy was used to check for cracks or delamination. Reflection mode was used on the left and transmission mode on the right. 3 of the parts were cracked, 4 were delaminated. Part number 4 is the only one to pass this test. The huge percentage of failures indicates that these were most likely recovered parts. Black topping can sometimes be seen under low magnification. These are 3 pin 1 markers having the same date code, and yet under magnification they are all different. Another black topping example. The middle part is the real one. In each part, the thickness of the bar, the text, and positioning are all different. The back of each part reveals that these were assembled in different countries but had the same date code. The bottom IC is the real part. Encapsulate on a chip is designed to resist solvents. A cotton swab with solvent revealed that the top part was treated with blacktop. Thanks for watching.